Today we are going to be doing fraction multiplication, and we are going to answer the question of why multiplication is justified in finding the numerator and the denominator. So first I'm going to introduce some definitions to you. The first definition I want to introduce is multiplication, and that is when you bring a bunch of groups the same size and count them all up. The next definition I'm going to focus on is fraction. Fraction is when you have the amount of stuff you would have if you took a whole object, sliced it into a bunch of equally sized pieces, and took some number of those pieces. Now, three other definitions that are important with fractions is the whole, and that is what you would have if you have 1 instead of a fraction. The denominator is the number of pieces the whole is cut into, and the numerator is the number of those pieces you have. So today we are going to be doing 7/3 times 4/5. So right away I'm going to focus on 7/3. So as we said before, the denominator is the number of pieces the whole is cut into. So we know that the denominator, which is on the bottom, is the 3. So we know that, let's say we have a chocolate bar, we are going to cut it into 3 pieces. And equally sized pieces, right? However, we are taking 7 of those pieces because the numerator is the number of those pieces you have. So we see we have 1, 2, 3 pieces here. So we know that we need more because we need to take 7. So we're going to have to draw another hole. So because the denominator says we cut into 3 pieces, we cut this hole into 3 pieces. So now we have 1, 2, 3, 4, 5, 6. So we still need one more hole because we need to take 7 pieces. So we'll cut that hole again into 3 pieces based on what the denominator is, which is 3. So that's the number of pieces you cut the hole into. So now I know I'm going to be taking this whole bar because we need to go back to the numerator, this whole bar because that'll be 6 pieces, and only one of these because that'll be 7 pieces. Okay. So now, because I am multiplying across, I need to introduce the other fraction. So the other fraction is 4/5. So like we paid attention to the denominator in 7/3, we need to pay attention to the denominator in 4/5, which is 5. So if I am multiplying across, right, because the definition says bring a bunch of groups the same size and count them all up, I am going to need to cut the chocolate bar into 5 pieces as well. So I'm going to do that across for all 3 of them. So have 5, 5. So now when we go to the numerator, I am going to see that there's 4. So I am taking the number of those pieces that I have. So I'm going to fill in. So I'm taking 4 out of those 5 pieces. So 1, 2, 3, 4, and I'm going to do that all the way across, right? Because we did that because we're taking 4/5 out of each piece, and we are out of the 7/3. So 4/5. So now I'm going to ask ourselves, so why did we multiply? And we multiplied because we had 7/3 of a bar and we multiplied it times 4/5. So if you know your basic fractions, you would know that 7 times 4 is 28 and 3 times 5 is 15. Now if you look back at each picture, we're going to go back to the definition of the denominator, the number of pieces the whole is cut into. So the whole is cut into 3 pieces here as well as 5 across. So that would represent the 15. Now the 28 would represent, because we have, I accidentally colored that, but we wouldn't have those pieces. Because we took 7 of pieces of the whole, right, like what the numerator says, and we multiplied it by 4 because we only took 4 out of the 5 parts on the other fraction. So that would get you the 28. So like we said, is we brought we brought some groups the same size together, right? We have 7 groups with 4 colored in, just as we have 3 groups cut into 5. So equal groups, and we count it all up. So now if we were to count it all up, we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. 28. And that is how we get our answer of 28/5, and that is why you can multiply across to find the numerator and the denominator using multiplication.